In this video, we're going to discuss the operation of a vector network analyzer. This picture shows a simplified vector network analyzer. It features a signal source, a pair of directional couplers, and a few termination resistors that are matched to the system impedance. Two sets of switches are turned on and off in sync to configure the behavior of the system. If the A switches are on, then the generator signal will propagate forward through the lower coupler. The generator signal will interact with our two-port DUT, generating a transmitted wave, which will come out on the coupled port of the upper coupler, and a reflected wave, which will come out on the coupled port of our lower coupler. Flipping the switches to the B configuration will run a signal through the upper directional coupler that will also result in transmitted and reflected signals appearing on the directional couplers. But those signals will be a result of the wave hitting the top part of the DUT, so they're interacting with the other port relative to the waves that were passing during the A configuration. Comparing the coupled signals to the amplitude of the incident wave allows you to calculate each of the four S parameters. The components in the VNA can introduce errors into the VNA's measurements. We've already talked about how directivity in the directional couplers could be an issue, so I've let it off this slide for now. But we're going to discuss another potential issue called source mismatch. This instant wave A1 will have some reflection off the DUT, and that signal will go back from the through port to the input port. That's fine. We expect that signal will be terminated by ZS, which we assume is matched to Z0. However, if there's some mismatch, then some signal will get reflected back towards the directional coupler. We use the symbol delta to represent the fraction that gets reflected as the result of this source mismatch. The reflected mismatch signal passes through the directional coupler, creating an error as a result of finite directivity, so this term. The reflected mismatch signal also continues on to the DUT, passing through the through port, then gets reflected off the DUT and coupled out as it is incident on the through port. There are other terms in this error expression resulting from continuing reflections from the source mismatch. However, we're assuming delta is kind of small, so all of them will be higher powers of delta and therefore negligible. Source mismatch is going to matter most when the DUT is highly reflective, so when gamma is close to 1. In summary, vector network analyzers use directional couplers to measure transmitted and reflected waves. VNAs switch between driving and terminating ports to measure all four S parameters. And source mismatch adds directly to errors, especially if gamma is high.